Section 4.2 is where we're going to analyze graphs of polynomial functions. So the first thing we're going to look at is how many turning points a function can have. So definition, you're going to look at how many relative maximum minimums or absolute maximum minimums are going to be on the graph. The maximum number of turning points is equal to your degree minus 2. So for example, let's say you had this picture. This would be a relative max. This would be a relative min. So you would have 2 turning points. This will tell me how many there are just based off of looking at the equation. So if I look at this first function, I can determine how many turning points there are by looking at the degree. So my degree is 4. So I would do 4 minus 1, so that means I have 3 turning points. Pause the video and try the next question. So on the next question, your degree is 3, so you should be taking 1 away from 3 and getting 2 turning points. So on your next task, we're going to look at your turning points and we're going to find where those relative minimum and maximums are. So if you wanted to copy down these keystrokes, this is what we're going to be utilizing. So we're going to type in our equations where that is in the y equals spot. We're still going to go back to second calc, and then this time is where we're going to utilize the minimum and maximum buttons. So I'm going to go ahead and type in our first equation. So I'm going to y equals, typing in x to the third. So here's your exponent button. Remember that caret key right above the divide sign. Then I have plus x squared minus 5x and minus 2. And then I'm going to go to my graph. I can see that we have 2 turning points. So I'm going to find where those are at. So this would be a relative maximum because it's a higher point. This would be a relative minimum because it's a lower point within that valley. So I'm going to second calc. Here are where my 2 maximum and minimum buttons are. Now you have to pay attention. So if I'm using number 3, the minimum, I have to make sure I'm left and right of the minimum on the graph. Otherwise, you're going to confuse the calculator. So here's my minimum. So I just want to make sure my cursor is left of that minimum. Then I'm going to scroll over and go right of my minimum, just like we did with our zeros. And then it's going to give me my relative minimum. So this is trying to round all the way to positive 1. So I wrote it at 1, negative 5. Then I would do the same thing for my relative max. So I'm going to the maximum button now. And then I'm going to make sure that I am left and right of my relative max. So I am left of that maximum up there with my cursor. I'm going right of that guy over there. And then I'm hitting enter. So my relative maximum is at negative 1.6 repeating, and then about 4.48 when you round. Now, if you get errors, it's because you're either using the wrong button for the wrong hump. So what I mean by that is if you click minimum and then you're trying to do the minimum over here, your calculator is going to say, no, that doesn't make sense because this is not a minimum. Also, make sure you're staying left and right of this spot. So make sure you're not taking your cursor clear over here past the other hump or the valley because you're going to confuse the calculator. So make sure you're staying close within that maximum or minimum. Okay, so pause the video and try the next question. So in the next question, you should have found these values. So if you type it in there, 4x to the third minus 7x squared minus x plus 3. You're going to end up getting this picture. So you should have 2 turning points. So you should have used your minimum button to find this one. So that's the 1.23 and the negative 1.38. And you should have used your maximum button to find this one over here. And that's the negative 0.68 and the 3.03. So 2 targets for this, making sure you can find the relative maximum and minimum using a graphing calculator, and then also realizing those are your turning points, right? That's where your graph is starting to turn in terms of increasing and decreasing, so we can find how many of those are based off of our equations.